control contains mainly two types, decisions and loops. Decisions are also about selection, which is the branching of flow based on a decision. And loops are also repetition, which is the looping of flow to allow statements to be repeated. A decision example is like the following, which is very simple temperature decision, if-else statement. If temperature is larger than 90, we display too hot, need to turn on AC. Else if temperature higher than 70. This means the temperature is within the range of 70 and 90. We display normal operating range. Else display too cold, turn on heater. And this is the case when the temperature is lower than 70. And the if statement always ends with the line end. So in these decision statements, we always use logical conditions. The first, most widely used logical condition is not, which is used to perform logical negation on an expression. And another one is and, which is used to perform a logical conjunction on two expressions. Or, used to perform a logical disjunction on two expressions. Here is an interesting example, which shows us the priorities of the logical condition operators. So here we have a equals -1, b equals 2, x equals 1, and y equals the character b. And character b is in the range of 33, 34, about that range. And the larger, the further characters will take bigger numbers. So we are going to come up with a decision of true or false for the current logical condition, which is a times b larger than 0 and b equal to 2 and x larger than 7, or not y larger than the character d. So the comparisons have higher priority than the logical and or. And the parentheses have the highest priority overall. So here, the first step, we are going to execute the comparisons and the parentheses. So a times b equals -1 times 2, which is -2. Is it larger than 0? No. So it came to the result false, which is f. And 2 equal to 2. b is 2, right? b is given 2. So 2 equal to 2 is true. So we return true for this statement. And 1 larger than 7, because x is given as 1. This is false. Or not, parenthesis. Character b larger than character d. As I just mentioned, going further with the characters, it associates with bigger number. So this is false. In the next step, we are going to execute the first logical AND, which is f true, false and true, which give us false, and false, or not false. So not false give us true. So in the next step, we have false and false, or true. False and false give us false. And next step, we execute the lowest priority, logical or, f or t. In the end, we get the result t, which is true. So the decisions for this logical, so the result for this logical condition analysis is true. So here are some more introductions of the relational operators. Some we just used, less than, greater than, not. And here is a list of all the operator's priorities. As we can see, the highest priority gives to the parenthesis, and the lowest priority gives to the element wise or. So here, next we talk about the for loops. We just finished talking about the decisions. So here is the for loop. For loop is for repetition, as mentioned. So the typical for loop form is the first line of the for loop is for variable equals expression, and the body of the for loop is command lines, and it always ends with the end line. And an example of for loop is for t equals 1 to 500. That means t will loop from 1 to 500. So the command for this for loop is yt equals sine 2 pi t. So for each of the t value, we calculate a y value, which is sine 2 pi t. So in the end, we will get a y vector regarding t values from 1 to 500. So another flow control, loop control is while loop. Similarly, it has first line while expression, and the body of the loop is commands, and in the end, it has an end line. An example is as the following. We have an initial value for the variable EPS equals 1. While 1 plus EPS larger than 1, we will execute EPS as half of EPS. So each time we cut the EPS into half until 1 plus EPS is no longer larger than 1. We will end this while loop. And in the end, we give EPS equals 2 times EPS as our final EPS value. So there is a break statement which is not shown in the above examples. Break is used to terminate the execution of the loop immediately. So we will talk about, you will have the opportunity to practice using break in your lab exercise. So this is a function example using for loops. In fact, most of the built-in functions or the functions that you are going to generate will somewhat involve loop controls using either for loops or while loops. So in this example is to calculate the factorial of n. Initial value x equals 1. Here it has a mistake. The x equals 1 should be a line, a command line, not in the commented line. So for I equals 1 over n is the input of the function. X equals x times I. So for each I value in this for loop, we get an x value, which is, if you look at the structure of this, first I will be 1, right? And x is 1. So x will be 1 times 1. And then after this command, I will be increased to 2. So x will be given a new value, which is x times I, which is 1 times 2. Now x is the value 2. And then I will, after this command, I will be increased to 3. And x will be 2 times 3. And then in the next loop, x will be 6 times 4. So going on and on, in the end, we get the f out equals x, which is the output of the function, also the factorial of x.